Hey y'all, in this video I'm going to show you two different problems that involve resultant vectors and finding either one or both of the components of them. The first problem that I have here is talking about a submarine diving 110.0 meters at an angle of 10.0 degrees. You can see that I already drew the picture here. So this is the horizontal, 10 degrees below that would be here. This is the resultant vector. That's what it's giving us, 110.0 meters at that angle below the horizontal. What are the two components? Okay, the two components are these two pieces here. This is the horizontal component. This is the vertical component. First, I'll find the distance vector, okay, because this is a distance that we're talking about. I'm going to do the vertical component first, so you can put y here, or you can put v for vertical, whichever one you want, equals, okay? Then it's the magnitude of the resultant vector, 10.0 meters, times sine. The reason that we're going to use sine is because this is the vertical component. Okay, or if you want to look at it on the right triangle, if you drew this, then sine is opposite over hypotenuse. This is the hypotenuse because here's my right angle. So sine of my angle, which is 10.0 degrees. Okay, then I just have to put this in the calculator. 110.0 times sine 10. Okay, this answer is 19.101. We need 1, 2, 3, 4 sig figs. We usually don't ever base it off of the angle because this is the distance that was given me and I'm reporting part of that distance, the vertical component. So we're going to use that one as my sig figs rule. So 1, 2, 3, 4. I need to keep 1, 2, 3, 4. So 19.10. And then it's this unit right here, meters. Now I'll do the horizontal component. So my x component. Same thing, start off with the magnitude. But this time it's cosine. Horizontal will always be cosine 10.0. Okay, the reason it's cosine is I'm finding the horizontal component. This is the angle that I'm talking about, so that's the side that is adjacent. And cosine is adjacent over hypotenuse. Put this in the calculator. Almost the same thing, but instead I'm using cosine. Also didn't put all the extra zeros. And again, I need 4 sig figs, so 108.3. And don't forget your unit. Okay, for all of these, make sure that you have the correct number of sig figs and you have your unit. Now, that's the first part of this question. What are the two components of this dive? That's the vertical component and the horizontal component. What do these values tell us? Okay, 19.10 meters is the vertical distance dived, okay, by the submarine, and 108.3 meters is the horizontal distance dived. And that fully answers that question for us. The next problem that I'm doing is a plane flies in a direction of 26 degrees north of east at 420 kilometers per hour. How far north has the plane traveled in 120 meters? So there's a lot more numbers on this one, as we can see. So we're going to have to figure out exactly what we're trying to do in order to solve this one. Notice that it's giving you a speed. It gives us the angle, but it's asking how far north. Okay, how far is distance? And then it also gives me a time. So this velocity, okay, that's a speed, velocity, distance, and time. We need to first figure out what the distance is going this rate, this velocity, in this amount of time. Then, when I figure out the vertical component, how far north, it will be in distance. Okay, so bear with me just a second. I'll go through the steps and then I'll re-explain it one more time. The first thing that we're going to use is the velocity formula, which is velocity equals distance over time. Okay, for this one, I'm going to rearrange this because I'm trying to solve for this. Okay, so I'm going to rearrange this formula. In order to do that, I will multiply by time on both sides to get rid of that fraction. And now I have distance by itself. So distance equals velocity times time. And I'm going to plug in the things that I know. I don't know the distance. I know the velocity, 420 kilometers per hour. And then I'm going to multiply that by the time. The time is 120 minutes. Okay, the issue here is this minutes and hours is not going to cancel. So in order for me to cancel that, I could have written 2 hours here because that's a nice, easy conversion. Or if it's not, then you can go ahead and put another fraction here that changes that for you. So I'm trying to cancel out hours, and that unit is on the bottom, so I need to put it on the top. And then I can cancel out these minutes here. Okay, the reason that I want to cancel out minutes is because I'm trying to find a distance, and distance will be measured in kilometers. Okay, so I have to get rid of this. So the hours cancel. Now the minutes will cancel. In 1 hour, it's 60 minutes. And then I'll be left with just kilometers. These hours cancel, these minutes cancel. Okay, so I used the formula, distance equals velocity times time, but I had to add this conversion here so that these units would cancel, otherwise they would not, and it would be a disaster. Okay, so this distance is going to be 420 times 120 divided by 60. If you put that in the calculator, you can do it mentally. You end up with 840 kilometers. This is my vector, and it's at this, which we already were given, 26 degrees north of east. Okay, I have to do that conversion first because now I can figure out how far north. Let me draw you this picture here. So a plane is flying in a direction north of east. So here's east. North of east would be above that. We'll say this is the 26 degrees. Okay, it's going this way. Now I know that distance is 840 kilometers. Okay, before I could have put a speed here, but that's not going to help me figure out how far north. If this is the distance that the plane is flying, I can find the horizontal component. It'll tell me how far east it flew. And I can find the vertical component, and that will tell me how far north it flew, which is what I'm trying to do. So some of these are not just plain and simple of you're given the vector and then you figure out what the components are. Sometimes you've got to make sure that it's in the right unit or the right measurement first. And that's what we had to do for this one. So now I can figure out what this side is, and that will tell me how far north it traveled in 120 minutes, because we already took care of that 120 minutes here by figuring out the distance that it flew in that 120 minutes. To find the vertical component here, you're going to use sine again. Anytime you want to find the vertical component, you are using sine. Now I have my magnitude here. 840 kilometers times sine, and that angle was 26. Then just put that in the calculator. 840 times sine 26. Okay, my sig figs for this one, this is 420. That only has 2 sig figs, so my answer can only have 2, meaning I need to keep only the 3 and the 6. However, there's an 8 after this, so I need to round that up to a 7. But don't just leave it 37. I need to fill in this place with a 0 for the placeholder, because I can't just say it's 37. It needs to be 370. That's what it would properly round to. And then your unit is kilometers.